All right, number 12 has us looking at the function y equal to the natural logarithm of x raised to the x power. Now this is something where we can't use the power rule because the power is non-constant. Also, it is not going to be like the derivative of e to the x because the derivative of e to the x requires, is based upon the fact that we're taking a constant thing, raising it to a variable power. This is a variable base raised to a variable power, and the only way that I've suggested trying to do this sort of problem is to do logarithmic differentiation. Again, what that means is first we will manipulate. We're not doing any calculus yet, we're just doing manipulation. We will take the natural logarithm of both sides. So this, I haven't taken any derivatives yet. Let's just do this nice and carefully. I did the same thing to both sides, applied natural logarithm to both sides. Now the right-hand side, I'm going to apply some logarithm laws to manipulate it a little bit further. The left-hand side, I'm not doing anything to. The right-hand side, I'm going to use the log law that says I can take a power and bring it out in front. So I can bring down the power of x out in front, and I obtain x times the natural logarithm of x, or excuse me, x times the natural logarithm of x. Now I can take the derivative. I haven't done any calculus yet. This is all just manipulation. Now I'm doing calculus. So the derivative of the expression on the left-hand side is always going to be y prime over y. Again, that's just the logarithmic derivative. The derivative of the natural logarithm of anything is that the derivative of that thing over that thing. On the right-hand side, I'm going to have to apply the product rule because this is x times the function natural log of x. So the derivative of x is 1, and I leave the natural log of x alone. And then the second time around, I add x, and I take the derivative of the natural log of x. This again is the logarithmic derivative. The inside function happens to be the natural log of x, and so its derivative is 1 over x. And then I divide by the original function inside of the logarithm, inside of the outside logarithm that is, which is the natural logarithm of x. And I obtain this. X times 1 over x over the natural logarithm of x. And you can do some simplification if you like, whatever, but there is one final step we have to do, which is we have to multiply both the left and the right by y. And on the left-hand side, these y's cancel out. On the right-hand side, I'm going to replace y with its original expression. So what I get is on the left, the y's cancel out, and on the right, I write log of x raised to the x power. You can simplify this if you like, but again, I don't require you to do that. The only reason you would want to simplify this, where you would have to rather simplify this, would be as if you're actually going to apply this in some sort of context. But this function is crazy. I'm not going to have you do anything else with this sort of function on a test except take its derivative. And this is even harder than anything I'm going to put on a test, so just don't worry. All right, final answer, this thing. Great.